Welcome back to the Watchmaker's Workshop. I'm here in my own workshop in Nashville, Tennessee, and I want to take a little time today to show you all around my workshop to see the different workstations I have, the different tools I use, and the general layout of my workshop. And I say my workshop because there are lots of ways to lay out a watchmaking workshop. And in the future, I want to go and walk through other watchmakers' workshops. And then we'll be able to kind of compare and see the differences of how every individual watchmaker sets up their own personal workshop. It's like a thumbprint for a watchmaker, the way they organize their workbench and organize their tools and materials. So today, we'll take a look at how I've set up my workshop here in Nashville, Tennessee. So this here is my main workbench. This is the spot where I'm doing most of my assembly work for movements, cases, dials, hands. It's going to take place at this workbench. So I have all of my main hand tools that I use regularly in this workbench. And this workbench is in a section of my workshop which is where all of the components that are finished, the components that are made, whether they're made in this workshop or made in another workshop, this is where they all come together when they're in an almost finished state. I have other workbenches in this grouping here that I use for special tasks. Things like setting crystals, pressing case tubes, doing quality control and inspection of components. So I actually have 4 benches in this little pod. And all of that is required in order to assemble movements, assemble cases, do case up and dial and hand work, and turn what is essentially a pile of parts into a ticking watch that actually keeps time. In this area, I have good lighting, I have compressed air at the bench tops, I have water testing equipment, I have timing equipment, microscopes. I also have winding machines that test the watch over time to make sure that it's not stopping in certain positions or running very fast or very slow over a certain period of time. I also have cleaning machines, and the cleaning machines are used for every watch before the movement is assembled, but also if a watch is 5 years old and it needs regular service, this is where that service would happen, where the watch would be completely taken apart and that movement would go back in the cleaning machine in order to be put back together clean with fresh oils. So this is what almost every watchmaker will have. They will have these assorted tools in order to do all of the specific watchmaking tasks. And that'll be pretty similar in almost all watchmaking workshops. The difference will be the different touches that individual watchmaker bring to it. If someone's been watchmaking for 50 years, they might have a very different setup with a different set of tools, vintage tools maybe. Or if somebody is working on very modern watches, they might have a very different setup where everything is very new and sleek and modern. Depending on what you're doing, that will kind of determine how you set up your workbench, the age of the tools you are using, the style of the tools you are using, whether certain things are old analog versions or new high-tech digital versions. As an example, I have a relatively high-tech microscope. Other watchmaking workshops might have very low-tech microscopes for doing tasks that are very different than what might be done in my workshop. Before actually having parts to assemble, those parts need to be made. Whether they're made in my workshop or another workshop, they'll all come together at the watchmaker's workbench. Right here, I'm standing in front of one of the machines that I have in my workshop, and this is a very large machine for watchmaking. This particular machine I use for making watch cases. And watch cases, they are the largest part of a watch. The case and the case back. They start from a pretty large piece of material, and it's also a very hard piece of material, either titanium or stainless steel. And the harder and larger the component, the bigger the machine has to be. The more powerful the machine has to be, the more rigid the machine has to be. So this is a relatively large machine to make a watch case. And this watch case is cut from a bar of raw material like this. Inside of a machine like this, there are tools like this one, up to 48 tools. And there's even little tiny tools for cutting really small features on watch faces. Now, a machine like this will run once it's programmed and set up. In order to program it, I have a different workstation because that workstation is dedicated to design, things like CAD, computer-aided design, and CAM, computer-aided manufacturing. And that is run on a computer workstation. Then I can bring that over here, set up this machine, and actually make the part I want to make. So in the machining section of my workshop, that's where I'll take raw materials, bars of steel, brass, and turn them into watch parts by cutting them. This machine here is a lathe, but not just any lathe. This is a sliding headstock lathe, also known as a Swiss lathe, because these were developed in Switzerland to make parts for the watch industry. And I feed this machine small bars of metal. I put a 6-foot long bar, this diameter, into this machine here. And I can cut parts on this machine that are as small as a grain of rice, if not smaller. Anything under 4 millimeters in diameter, which that includes almost all watch screws, pinions, winding stems. Any of these components can be cut on this machine from long 6-foot bars like this one. I also have a larger Swiss machine behind me, and that Swiss machine can cut parts up to 1 inch. So that can be used for cutting parts like mainspring barrels. It can also be used for cutting parts like watch crowns. It could be used for cutting wheels, which are the large diameter part that goes onto the pinion or the pivot. So anything that's over 4 millimeters is too big for this machine here. But it can go on the other machine, which will cut parts up to 1 inch, which means I'm feeding a larger diameter bar into the machine behind me in order to make those larger parts. Because with this kind of machining, we have to start with something that is larger than the part we are trying to cut. Just like a sculptor would take a large piece of stone, carve away what they don't want to reveal the sculpture inside. That's what we do when we're machining. We're starting with a piece of metal, removing the parts we don't want, to then show underneath that the screw or the pinion or the crown or the barrel. So these two machines both have what's called a bar feeder attached to the back of them, which feeds long bars into the machine and supports them as they're turning and being cut. With a Swiss-style lathe, the whole bar is spinning, even though we're only supporting the part at the very front. So the bar feeder will support the bar in the back and also make sure that when we want to cut the next screw, we can push the bar into the machine to feed more material. And at the end of the day, that bar will be completely gone, transformed into little tiny screws for a wristwatch. Machines like these are pretty rare in the US. There are some shops that specialize in these kinds of machines for making parts for the medical industry and the aerospace industry, jet propulsion, things like that. However, there are no workshops in the US that are specializing on making things such as pinions for the watch industry. And a machine like this one, 4mm and under, that is set up for hobbing gears for watches and making very highly complex components that go into wristwatches. They simply don't exist in the US. This is one of the most advanced machines for small turning in the USA. Other industries that use a machine that makes such tiny parts are usually making components that are very simple. For electrical connectors that go into missile systems, anywhere you wouldn't want that electrical connector where you have one male end, one female end, these pins need to be perfect so that there is no fault in that electrical signal. So tiny little gold pins will be made on a machine like this that can do that perfectly. But in the scheme of things, those are relatively simple parts. When we're talking about tiny pinions with 7 leaves on them that might have an overall diameter of less than 1mm and an overall length of up to 4mm, these parts are extraordinarily fragile with very tight tolerances. And as you cut at the end of a part, there will be deflection in the bar, unless you have a very special machine that is a Swiss-style lathe or sliding headstock machine.